To derive the moment generating function of the Bernoulli distribution, that is for a random variable x, that has a Bernoulli distribution with a parameter p, we will use the definition of a moment generating function, and that is that the moment generating function, which is written as m of x t, is equal to the expected value of e to the power of t x. Now we don't need to know what t is to be able to derive this function. It's not really relevant to the use of the moment generating function. But for this we'll use the definition of what an expected value is for a function. So the expected value of any function g of x is, now because this is a discrete distribution, we'll use a summation rather than an integral, but the sum of the function g of x multiplied by the probability, so the PMF. Now for a Bernoulli distribution, the PMF, P of x, is p to the power of x multiplied by 1 minus p to the power of 1 minus x. And so then we just use this to generate the function. So the moment generating function, the expected value of e to the power of tx is equal to the sum of, now because a Bernoulli distribution can only take on the values 0 or 1, we start at x is 0 and go to 1, of the function g of x, which in this case is e to the power of tx, multiplied by the PMF. So multiplied by p to the power of x, 1 minus p to the power of 1 minus x. And then we can just go ahead and input the values of the summation because there are only two values. So this is equal to, if we start with when x is equal to 0, it gives us e to the power of t 0 multiplied by p to the power of 0, 1 minus p to the power of 1 minus 0. And then we want to add when x is equal to 1. So e to the power of t 1 times p to the power of 1, 1 minus p to the power of 1 minus 1. Now anything to the power of 0 gives us 1. So this means that we've got e to the power of t 0 becomes 1, p to the power of 0 becomes 1, and then we've got 1 minus p to the power of 1. So that just stays as 1 minus p, and then we've got plus e to the power of t times 1, it's just e to the power of t. We've got p to the power of 1, so that's just p, and then we've got 1 minus p to the power of 1 minus 1, so that's 1 minus p to the power of 0, and so that is just 1. This means that we can rewrite this as 1 minus p plus p e to the power of t. And that is the moment generating function of a Bernoulli distribution. So mx of t is equal to 1 minus p plus p e to the power of t.